Pre-AP calculus, solving oblique triangles. That means solving a triangle, finding the missing parts, but it's not a right triangle. This is a review from geometry. Law of sines we're going to discuss in this video, and law of sines in the next video. Law of sines. Let triangle ABC be any triangle with sides A, B, and C. Let me just draw any triangle. Sides A, B, and C, representing the measures of the sides opposite angles with the measures A, B, and C respectively. It means in the same order. Then, if you take sine of an angle over its opposite side, that ratio will equal sine of a different angle over its opposite side, which in turn equals sine of an angle over its opposite side. Law of sines is all about using an angle and the side opposite that angle. When can you use law of sines? If you're given the measure of two angles, if you get the measure, of two angles in any side of the triangle. So if you know an angle, and then any other side. The reason it doesn't matter the side, because if you know two angles, you could always find the third. So any side you're given is going to be relative to any of those angles. Or if you are given the measure of two sides and an angle opposite one of those sides. So let's say that you're given this angle here. I just put the sides where the angles are. Let me do that again. If you give the measure of two sides and any angle opposite one of those sides. These are the two cases you can use law of sines. Here's how I prefer to remember it. If I'm given an angle and the side opposite that angle, I can use law of sines. And I just have to have one extra part. It could be an angle or a side. Doesn't matter where it is. That's when you can use law of sines. Let's look at an example. George fenced in a triangular area for his pet parakeet. Two sides of the area are 160 marshmallows long, and they meet at an angle of 85 degrees. If the fence is to be built around the area, how many marshmallows of fencing will be needed? So he has a triangular area. Two of the sides are 160 marshmallows long. I'm just going to say this one's 160 and this is 160. They meet, they meaning those two sides, at an 85-degree angle. How many marshmallows of fencing will be needed? So it's asking for the perimeter. So we have to add up all the lengths of all these sides. For giggles, let's just call this side, this angle B and this side B, angle A, side A, angle C and side C. First of all, can we use law of sines for this problem? The answer is yes, because we, wait a second. Drum roll, please. At first glance, it's like, well, we can't. We know this angle, we don't know the opposite side. We know this side, not the opposite angle. We know this side, not the opposite angle. But if we examine a little bit closer, if we think back to geometry, this is an isosceles triangle because two sides are the same length. The isosceles triangle theorem says that the base angles have to be the same. So let's just say that this is x. Triangle sum theorem, if you add up all the angles in a triangle, you're going to get 180. We subtract 85 from both sides, we're going to get 95, and then x is going to equal 47.5. So after doing that work, now we can use the law of sines. Once again, we can because we know the measure of a side and the angle opposite of it. So we're going to use that as our starting ratio. Sine of 47.5 degrees over its opposite side of 160 has to equal sine of 85 over its opposite side, 85 degrees. This is the law of sines in action. Trying to solve the equation for B. So I'm going to try to separate my variable from sine of 85. I don't have to multiply both sides by 160 because this is fine where it is, but I'm going to because most students like this better. I'm going to multiply both sides by 160 in b to get rid of my fractions. On the left, the 160s cancel. On the right, the b's cancel. So now we have b times sine of 47.5 degrees equals 160 times sine of 85 degrees. Pro tip, if you're multiplying a number times a trig function, put it on the left. Trying to get b by itself, so I'm going to divide both sides by sine of 47.5 degrees. It's going to give me b is 160 times sine of 85 degrees divided by divided by sine of 47.5 degrees. Put that in your calculator, and you get b is approximately 216. I did not round to 3 decimal places. Here's why I didn't. I've told you always round to 3. The directions say how many marshmallows. So if it says how many marshmallows, well, let's not be hypocrite. Let's be a hypocrite. Let's not be hypocrite. Let's get my calculator out. See, we're in degrees. 160 sine of 85 divided by sine of 47.5. Misinterpreted this. 160 times sine of 85 degrees. All right, so it's 216.189. Hypocrite avoided. How many marshmallows are needed for the entire fencing? So that's going to be the perimeter, which is 160 plus 160 plus 216.189, which is 536.189. Sentence answer, George needs 536.189 marshmallows. All right, next video we're gonna review law of cosines.